All right, so the first topic we're going to cover is the rebuilding time. So we have this part over here, and as you guys can see, it's got patterns to it. It looks right over here, but if we go to evaluate, if we do performance evaluation on this part, it shows that it takes 16 seconds to rebuild this part. Each feature also shows how long would it take to rebuild. If we go, for example, to one of those patterns, like the pattern itself over here, and let me zoom in and try to do edit feature. As you guys can see, this pattern, looks fine, but sometimes we make the mistake of, over designing our part. For example, if I'm going to add multiple instances here and multiple instances in this direction, that's not really going to affect the shape of my part, because when you hit OK, when you click on it, it's not going to show in the part. However, it's going to change the total rebuild time. And even each feature, here they're sorted by, the highest to the lowest, also increases the time for it to rebuild. So if I go ahead and undo those changes, keep in mind, guys, it's at 27 seconds now. If I go back over here, it went back to 17 seconds because it undid the changes that I made. In other words, let's always keep in mind to optimize our designs, and even though it won't show up over designing our part, it won't show up on the actual part, but it will increase the rebuild time on that part. So let's go ahead and close that part and talk about how to examine and suppress unneeded features. So if we have this part, for example, it's made up of, let me roll back up to here. It's made up of all of those features, from the extrude to the helix to the chamfer. I'm just trying to walk through the part and show you guys, how many features does it have. So let me go ahead and suppress the chamfer 1 and chamfer 2. So let me suppress them. Guys, it's always a good practice to, if you're looking to simplify your model, instead of deleting features, it's better to suppress them first and then delete them. So let me delete them, and yes to all. Now this is what happens, the what's wrong box pops up. Let me close it, and in the feature tree we can tell that that whatever I just did, deleting those chamfers has generated some faulty equations. So let me see what's going on there. Let me go to manage equations and simply delete all those faulty equations. So select this one, and this one, and delete them. Close. There's one more. Let me go ahead and delete them. Okay, so now it looks fine. You can also use breadcrumbs to suppress or unsuppress features. For example, if I have this feature here, the breadcrumbs shows up here, but let me hit the D button and bring it down here. So cut sweep, I can suppress it from the breadcrumbs, just like grabbing any part from the feature tree. So all I did is just accessed the unsuppress command from the breadcrumbs, so I didn't have to look for it in the feature tree. So let me go ahead and delete the cut sweep. Delete it. And the helix and spiral. and sketch 3. Helix and spiral. Close. And the sketch that was associated with the cut sweep. Alright. Now guys, keep in mind that this view is still nested in case you guys want to view the tree in an expanded mode, you know, as a flat tree. All you need to do just you know, exit from the tree display, you know, show flat tree, and it's going to show you all the sketches that were you know, maybe that belonged at some point to the features that we went ahead and deleted them. Again, let's access those equations and delete them, all those faulty ones. Let me see if there's any more down here. Alright, click OK. And let me go ahead and suppress the cut extrude, this one here, cut extrude 2 and sketch 8. Let me go ahead and suppress them, and instead of deleting them, I'm going to show you guys how to another way to get rid of them by using the purge unused features. All we need to do is just right click on the main part in the feature tree and say purge unused features. So for this one, I'm going to say OK, yes, and let's do it again so it gets rid of this sketch 8 over here. Purge unused features, and yes. Okay, I'm gonna go ahead and see if anyone has a comment here. Why do you suppress first? Here's a question by John Schneider. John, it's always a better practice to suppress your features first to see how it's going to interact in the part as a whole. Like, for example, you don't want to delete your feature first and then change your mind. I'm not going to say it's going to be too late, you know, if you delete something, because you can always undo things. But I would say suppressing a feature would give you a preview of how your whole part is going to look like. It's going to, at some point, it's going to reduce your rebuild time before you go ahead and delete them. And always remember, whenever you're rebuilding, the Control Q, which is the hard rebuild, takes a longer time than if you do just a normal rebuild, which is the Control B. Alright, so let's close this part. And let's take a look at how to clean imported models. So this is a step file that I'm going to go ahead and open. So it's asking me if I want to run import diagnostics on this part. I'm going to say yes. Alright. So for the faulty faces, let me highlight it and tell it to attempt to heal all. So I don't have any faulty faces anymore. All I see in my feature tree is this imported part. Now let me change my view to shaded with edges to see how many ways I have to simplify my part. Let me access one of those fillets right here, one of those whole fillets, and tell it to delete face. Delete and patch. Okay. So as an approach to simplify my part, guys, you know, I went ahead and deleted one of those fillets. But sometimes when you have a part with multiple features like that, you don't want to be doing these things individually. That's why let me undo this tip. Let me go back and undo. And from the feature tree, let me right click on my imported part and recognize features. Let me run it from FeatureWorks to recognize all the features in my imported part. It's going to prompt me to choose what features to recognize. Keep in mind, guys, you know, what you're looking for in a part. Like, you know, the less you choose from here, basically is going to reduce the rebuild time, you know, the part generation time. So, you know, whatever you think that you don't need, it's a better idea to you know, toggle them off. That's why for this particular model, I'm gonna toggle on the extrudes, resolves, holes, and fillets and chamfers. You know, and let me go ahead and do the recognize features. Let's click OK here. Alright, so now we have our part ready. You know, as you guys can see, you know, previously we had just the imported part. Now we have all the features that, you know, FeatureWorks was able to recognize. You guys can see, like, there's a cut extrude 1, cut extrude 2, cut extrude 3. That's how SolidWorks recognized them. You know, I know that it would be a better approach to, you know, do one cut extrude and do a pattern for all of them. Let me go ahead and suppress and delete fillets 1 and 3. So this is fillet 1. Let me make sure that, yep. And this is fillet 3. And those, there's another approach for us to simplify this part as a whole, is to get rid of those inner ribs right here. So let me open up a sketch at the bottom of the plate and tell it to convert entities from this edge. And again, convert entities here for this edge, and drag this whole entity to let it form a circle, and do a boss extrude for it through all. Seems like it's going to the outward direction. Let me make sure that it's going the proper direction. So I simplified my model, you know, from having a complicated geometry in here to a smoother geometry. You know, like you guys saw, it was all done by SCADs. You can always, guys, make changes. Let's save this part as a solid part, convert to bodies using convert to bodies, and that's going to allow me to save the step file as a solid part, so it won't consume time to open. We got converted, and it's asking me to convert to bodies. You know, convert one because they can't be the same name. Say OK. So guys, here there was another way to simplify our parts, to recognize our features, and to manipulate those features from what we need and what we don't need, and to end up with a simplified model that's gonna help the performance, our performance. Don't save. So let's take a look at a similar part, but this time we're going to see how to simplify sketch entities on that part. For example, okay, so this is a similar part like the one I was working with the imported model. Let me just go ahead and suppress fillets 3 and 4, you know, as an approach to simplify my model, and go to cut extrude 3 and edit the sketch on it. Let me highlight them all and mark them for construction. So allow me to go ahead and sketch a different entity, like a circle, for example, from the center to let it snip at one of those points. Let me exit out the sketch, and with a simple sketch, guys, I was able to simplify my model, from that complicated geometry in there to just the smooth geometry. And keep in mind, guys, what we saw before in the other part was just another approach using the convert entities. This was a different method. I can also go ahead and edit that sketch of all these entities. Let me do multiple selections here so I won't end up selecting the center. So select this group, control select this group, and I can clean them up later. This group and this group, just delete them. Again, delete, 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 and let me give it a dimension. I think it's at 54 here. Now let me make it 55 just for the show. And exit my sketch. Alright, so guys, that was just another way to, or another approach to simplify our models in SOLIDWORKS. Let me close it. And now the biggest news is how to deal with assemblies when it comes to assembly performance. So this is the assembly that we're going to be conducting our studies on. The first feature that I'm going to show you guys is the assembly visualization right here. And as you guys can see, let me expand this window here. It's at graphic triangles now. This is the sorting method. Excuse me, and it shows here how all of these components are being sorted, and depending on the criteria or the property that you guys have set up your sorting to be, it's gonna display the inputs with it doesn't have units, but based on that you guys will be able to tell what kind of properties that you selected. So let me enable the freeze bar here from options and enable freeze bar. It always helps, and you guys might know that, with rebuilding, especially in large assemblies, guys. Freeze bar helps you stop your part at a certain point, so the rebuild won't take a longer time because you have pre-specified where your rebuilds are going to be. Let me close out this one for a bit and open up the brace crossbar. Open up the part and stop it, for example right here, and say rebuild all the configurations now. So since I stopped my freeze bar right here, guys, it didn't include these, and you guys can see these padlocks, the padlock icons displayed next to the features, everything before the freeze bar. It didn't include those. This was like a simple part, but sometimes you might want to open like a sub-assembly within your assembly, and your feature tree would be much longer than this one. So the freeze bar would come in handy, if you're trying to make changes. Oops. But you don't want those changes to take a long time to rebuild. Let me just go back to the assembly and do the assembly visualization so we can think around with the sorting methods. For example, if you feel like changing the sorting method to do the mass, it's going to resort all those components, guys, from the heaviest to, you know, to the lightest. And using those colors, I can change the colors on those indicators here, on those scroll bars. You can choose whatever color you want. You can drag it down. Drag this other one and make it maybe blue. All right. Drag this other one. And here it shows, you know, the red with the heaviest parts, and, you know, the blue parts mainly the lightest. Let me probably, if I decrease the scroll bar here, it's showing that which part is the heaviest at that particular level, so on and so forth. If I expand, you know, the menu here, if what you're looking for, if the sorting method isn't showing up here, guys, you can click on more, and from the properties here, if you feel like, you know, choosing the open time as a sorting criteria here, you know, let me look for it. And this is pretty common, guys, in large assemblies. You know, the number one concern when it comes to large assemblies is which component is going to take the longest time to open. You know, let me sort out these parts, you know. And why am I doing this? Sort it from here, open time. All right. That helps us, guys, to determine which part is going to take the longest, so we can individually open up that part and, you know, do some changes to, you know, simplify that model. You know, again, let me tinker around with colors here. Just the open time for like the 0.3 seconds, you know, 0.203, so on and so forth. Let me open up this part. Like the example that we saw before, guys, in the second topic I talked about, like had to examine and suppress unneeded features. My evaluation in that list showed up that this part is going to take the longest time to rebuild. So, you know, I opened it up individually. What if I want to make changes here, you know, take less time, you know, evaluate it and see how does it perform and go from there. Also, we can add the property to sort those assembly components to be displayed by the rebuild time instead of open time. This is the rebuild time. Again, the components that's going to take the longest and the least amount of time to rebuild, or highlighted here from the blue color, you know, the least amount of time to the red color, the longest time. Let me open up the largest part here and say okay. You know, make changes to it. Just like we did to the screw, guys. Let me resort them to be sorted by the graphics triangles. And this is another big concern when it comes to big assemblies, guys. You know, graphics, sometimes high assemblies with high details could result in some complicated graphics. So we might want to be interested in viewing which component is you know, consuming the most out of those graphics. So let me go ahead and open up this part. So apparently this part was consuming a lot of graphics based on the graphics triangles that we sorted out. So this is the edge here that looks pretty circular. So if we're trying to decrease the graphics consumption on this part, because there's plenty of them, as you guys can see here, so it might be helpful to go to document properties, you know, from options, and get to display, model display here, image quality, and decrease that quality. Now, as you guys can see here, it doesn't look as nice and fine, and this edge wouldn't look smooth anymore. It will look edgy, but hey, it's gonna be for the sake so you guys can see the difference. It doesn't look as nice, but it'll serve the purpose. Let me go back to the assembly over here. So guys, you have plenty of options to think around with, to choose what's the best approach for you guys to choose, so you can make changes to your assembly, to your parts, to your sub-assemblies, and go from there. At the end, we can go to performance evaluation, and it'll give us a detailed list, for our assembly. Performance evaluation for the whole assembly. For example, here it's telling us that there were 344 mates evaluated, rebuilt, total parts and components, part documents, the whole 9 yards there. And in case you guys needed more help understanding what's going on, or is there any techniques or tricks or methods to help your assembly, there's a direct link from this button, from this help button, that's going to take us to the SOLIDWORKS help documents. Let me go over it here, expand it, performance evaluation statistics, for example. Just any topic that you guys can think of, you'll be able to find it in the SOLIDWORKS help documents. Let me close that out. Hope you guys enjoyed this webinar. You guys have learned a few techniques that's going to help you down the road with your assemblies, parts, and simplifying complex models.